Welcome, everyone. If you just take a look around you right now, from the cars sitting in our driveways to the smartphones we're all addicted to, and honestly, even the food on our dinner tables, there is this massive, silent shift happening in global industries. We are literally right in the middle of an automation evolution. So today's explainer is going to decode exactly how that evolution is happening. We're breaking down the truly fascinating world of industrial robotics. Whether you're an engineering student, a manufacturing pro, or just kind of curious about how the modern world is actually built behind the scenes, you are absolutely in the right place. Okay, let's dive into this. What exactly is an industrial robot? When we hear the word robot, our brains usually jump straight to science fiction, right? But an industrial robot is something very specific and honestly, incredibly powerful. Put simply, it's a programmable machine designed to handle complex, repetitive tasks efficiently, accurately, and relentlessly. I mean, we're talking about machines that can operate for tens of thousands of hours without a single coffee break. They are the ultimate heavy lifters and precision crafters of the modern factory, specifically engineered to do the dangerous, dull, or super complex jobs that human hands just can't pull off at scale. Here's how we're going to break it all down today. First, we'll cover the basics and anatomy. Second, types of robots. Third, real-world applications. Fourth, we'll look at Industry 4.0. Fifth, careers and maintenance. And finally, number 6, we'll peek into the future of automation. All right, let's kick things off with Section 1, Basics and Anatomy. These are really the building blocks of automation. Think of a robot's anatomy a lot like the human body. The controller, that's the brain, making all the complex decisions. The sensors and vision cameras act as the eyes and senses, constantly taking in the environment. Then you've got the servo motors and the mechanical arm. Those are your muscles and bones, giving the robot its strength and articulation. The gripper, or the end effector as it's technically called, acts as the hands, actually grabbing and interacting with the products. Then there's the teach pendant, which is kind of like the classroom. It's the interface we humans use to teach the robot new tricks. And wrapping that whole shebang together is the safety system, making sure the machine does its job without harming itself or the folks working around it. And this brilliantly illustrates how all these parts work together in a continuous, lightning-fast loop. Step 1, the robot receives input from its environment through its sensors. Step 2, the controller processes that vast amount of data in literal milliseconds. And step 3, it executes a highly precise physical action using its motors and arm. Sense, process, act, over and over again with absolute millimeter precision. It's wild. Moving right along to Section 2, Types of Robots. Essentially, having the right tools for every task. Now, what's really interesting about this is how specialized these machines have become. For instance, the articulated robot moves a lot like a human arm, which gives it this incredible flexibility for tricky tasks like welding. Now, if you need super fast horizontal assembly, you're going to use a SCADA robot. For mind-bending, high-speed packaging, think sorting chocolates on a fast-moving conveyor belt, the spider-like Delta robot is absolutely your go-to. Cartesian robots? They handle the heavy lifting on a strict grid. Then we have cobots, or collaborative robots, which are packed with advanced sensors so they can work safely right next to humans without needing those massive safety cages. And AGVs and AMRs? Those are the mobile robots zipping around moving materials all across the factory floor. Next up, Section 3, Real-World Applications and how they are transforming industries. Let's do a quick speed round here because robots are literally everywhere. They're welding the chassis of the car you drive. They're performing CNC machine tending and assembling super delicate electronics. But, it goes way beyond traditional manufacturing. They are picking and placing items in giant logistics warehouses to pack your e-commerce orders. They're ensuring completely sterile packaging in pharmaceuticals. They're even stepping into smart agriculture to harvest crops and pushing the boundaries of humanity in defense and space exploration by helping build and repair satellites. Their reach is just universal at this point. Which brings us to Section 4, Industry 4.0 and Integration. Welcome to the Smart Factory. Let's move to and see how this builds a completely new paradigm. Back in a traditional factory, you basically had isolated machines, you just reacted when something broke down, and all your data was tracked manually on clipboards. But a smart factory under Industry 4.0, that is fully integrated. The machines actually talk to each other, they share data in real time. Maintenance becomes predictive, meaning the system actually knows a part is going to fail before it physically breaks. It's a total game changer. And this is the ecosystem that makes that smart manufacturing possible. You've got PLCs, HMIs, and SCADA, which are essentially the industrial computers and touchscreens acting as the central nervous system of the factory, controlling and monitoring everything. Variable frequency drives, or VFDs, optimize your motor speeds. But the real magic, that happens when you introduce the Industrial Internet of Things, IIoT, and artificial intelligence. That unlocks advanced machine vision, remote monitoring from literally anywhere in the world, and digital twins, which are virtual replicas of physical robots that let you test processes safely in a simulation. Finally, data analytics ties it all together, turning raw numbers into actionable factory intelligence. Naturally, upgrading to all this advanced technology comes with some initial implementation challenges, right? But the return on investment is undeniable. We are talking about massive leaps in productivity and flawless consistency and quality. You see significant energy savings, long-term cost reduction, and honestly, most importantly, greatly enhanced worker safety, since the robots take over all the hazardous tasks. All right, let's pivot to Section 5, Careers and Maintenance. We can't forget the human element. Because let's face it, robots don't maintain themselves, at least not yet. Knowing how to keep these machines running is an incredibly valued skill on any factory floor. It all starts with rigorously enforcing safety precautions. Next up is preventive maintenance, regularly checking components before they fail. And finally, systematic troubleshooting. Look, when a robot stops on an assembly line, a skilled technician who can quickly diagnose a sensor error or a motor fault using that teach pendant, they are worth their weight in gold to a manufacturing plant. So the crucial point is this. The whole rise of automation is not just replacing jobs. It is actively creating highly skilled, high-paying new ones. To become a robotics engineer or technician today, you need essential technical skills like robot programming and a solid understanding of PLC integration. The future growth in this space is just exponential. Oh, and a quick tip for your interview preparations, please don't just memorize textbook definitions. Hiring managers want practical problem solving. Be ready to explain exactly how you would troubleshoot a specific safety system failure or how you'd integrate a brand new sensor. Finally, Section 6, the future. What exactly is next for automation? Well, the next era of industrial automation is absolutely going to redefine what we think is possible. We're moving toward much deeper AI integration, where robots won't just follow pre-programmed paths, but actually learn and adapt to entirely new tasks on the fly. Fully collaborative robots are going to become the standard, seamlessly sharing our workspaces. And we're already seeing the emergence of industrial humanoid robots designed from the ground up to operate in environments built for human ergonomics. The smart factory of tomorrow is virtually limitless. So I want to leave you with a bit of a provocative question. This industry is evolving at breakneck speed. The tools are there, the knowledge is available, and the demand for skilled professionals is higher than it has ever been. The only question is, are you ready to upskill and lead this next wave of the Industry 4.0 revolution? If you are ready to take that next step, I highly recommend checking out DEVI Automation Solutions. They're the premier experts out there offering modern automation solutions, hands-on training, and incredible industry services across PLCs, HMIs, SCADA, VFDs, artificial intelligence, IoT, smart agriculture, home automation, and even solar solutions. You can reach out to them directly at deviaautomationsolutions@gmail.com for training or industrial consultancy. Thank you so much for joining me on this explainer. If you found this valuable, please like, share, and subscribe so we can keep demystifying the technology that shapes our world. Until next time, keep learning and keep innovating.